Okay. I am going to get back to benchmarks. We are going to go over the problems that you missed and make sure that if we were to see something similar, that we wouldn't miss it again. Okay? Huh? It's possible that either on your final or on the end of course test, you can see something like it again. Okay, let's take a look at your homework. These are the answers for your homework.
I probably got all of them right. Okay, you stole it. I got 100 on the first problem.
I aced it.
And on the second problem.
Wait, so the equation for the asymptote would be just y
I'm not gonna lie, I got really tired of writing negative infinity, positive infinity.
Yeah, I was like every single question.
Okay, so you notice that the domain, no matter what exponential function you were given, was negative infinity to positive infinity. Yes, it is. That was a realization that I wanted you to come to, no matter what. Please sit down. All right. Also, when we look at the asymptote, an asymptote is a horizontal line, right? So if I ask you for the asymptote, you make sure you give me an equation, not just 0. The asymptote is y equals 0. You're giving me the equation for the asymptote. If I give you a blank that says asymptote and you just write 0, that's a value. I can't give you any credit. All right? Are we good?
Yes, ma'am.
And then one other thing I want to talk about quickly. Over the past couple weeks, I've been working really hard to keep my YouTube up and my website up to date. And just over the past couple weeks, I've had several students that have missed class or done different things and come up to me and they're like, "What did I miss? Can you go over it with me?" And I'll look at them and go, "Did you check the website?" "No." "Did you check the YouTube?" "No." And I was actually thinking of discontinuing them, not having the YouTube or not having the website, because it's a lot of extra work for me. It takes me probably an extra 30 minutes plus every day to keep those updated, which I could be doing other things. Well, my last 4 classes said, please don't take them down. And so there are students in every class that actually use them. So I'm going to make it your responsibility. If you're absent or if you're pulled out on a field trip or something like that, it is your responsibility to check the website and your responsibility to check the YouTube. That way I don't get, because I was taking it personal, and I know I shouldn't. I just, when I get really tired and overwhelmed and there's a million things going on, you know how sometimes you react inappropriately? I was taking it personal that you guys weren't using it, or some of you. But enough students do use it and do like it that I'm going to keep it going. But I need you to take responsibility if you're out. Now, Shannon did a great job. I mean, she was out a lot, and she kept up. So, sorry, didn't mean to call you out like that. But but, you know, I need, yeah.
More than Shannon's cooperation.
Exactly.
And I'm guilty.
Okay.
But from now on,
You're good?
I'm with you.
Okay, thanks. All right.
What?
Okay, any questions about 1 or 2? We're good? All right, let's keep moving.
Yeah, baby.
See, I got tired of writing it too, didn't I?
Yeah. I did.
All right, so
Done that.
on this one, everything was just like 1/3 to the x for 1/2 to the x, so I just said same as that.
I was
Tempted?
I was very tempted. I almost wrote same as, but then I was like, you know what? I'll get the practice.
Wow. Muscle memory. Good job. Good job.
Practicing that memory.
Okay, any questions on 3 or 4? Okay, so we noticed while we were doing it, these were increasing from left to right, and the base was bigger than 1. These were decreasing intervals, and the base is less than 1. So if the base is greater than 1, it's increasing. If the base is less than 1, it's decreasing. Okay, now I asked you to make a change on number 5. So if you did, yours should look like this. If you forgot to write it down, it's not going to look like this.
Mine, I
Just did that whole problem.
Okay, so the -1 shifts our asymptote down 1, and then the -2 takes it to the right 2. So we go over 1, up a third, up 1, over 1, up 3, sketch in our graph. And yesterday we talked about this as like the new origin, the new starting point. So our range finally changed. It's -1 to infinity. This one is increasing. This time as x approaches -infinity, y approaches -1 instead of 0 because it was shifted down 1 unit. And our asymptote is y equals -1. Yes?
Your pencil sharpener has now taken the life of my third pencil.
It went kaput.
Could I borrow a pencil? Thank you.
Okay, so 2 to the x plus 1 plus 2. So we're going to shift the asymptote up 2 and move left 1. Then we go over 1, up a half, up 1, over 1, up 2. Now if you wanted more points, you could test more points. If I went right 2, what's 2 to the second? 4. If I went right 3, what's 2 to the third? 8. Guess I should have, because mine was off a little bit, wasn't it? Oh, no, it wasn't. I just put that in the wrong spot. Okay. Any questions about 5 and 6? Yes, sir.
Was number 5 a vertical stretch?
No, we're gonna do. It was the original number 5 was a vertical stretch.
This is why we didn't do it.
Yeah,
Oh, I
but I
forgot
didn't have.
you changed it.
I didn't have a
I
chance
didn't write down the
to get
change.
to that yesterday in my teaching in second period, so that's why I changed it. All right, now this one, you can tell it's been shifted up too, but how do you know what the base is? Okay, what do you think?
Because when you find where like the origin is, then it goes like up 1 and then over 1, and so that would be like usually a 2
Okay.
in the y. So
Good noticing of the pattern. Also, if we look at this, if we go over 1, we go up 2. If we go over 2, we're up 4. If we go over 3, we're up 8. So those are powers of 2, aren't they?
Yep.
4, 2, 4, and 8. Those are powers of 2, so my base is 2. And both of these were base 2. Are we good?
I'm well.
Great. Okay. Today we're going to do some more, and I'm going to throw in vertical stretch and compression today. We're going to do some reflection today.
Yay!
Number 1 is you try though, so as soon as you get it, go ahead and take a shot at number 1.
I actually heard that song.
We're going to let Friday be
My friend was on Instagram she's on point. But she was singing it. She was like, don't let anybody bring you down.
No, that's a coincidence.
I don't see any.
Just saying that.
Number 1 is the you try.
Oh, well, it sounded pretty much exactly like it.
Okay, guys.
I was like, oh, that was Amy.
Please start number 1. Please start working on number 1. Yes. want you to have the folder to put the test in when we're done with it.
I told her about it, and she was like, you can take my word for it. She's like, I see.
Get out of here. Go away.
I showed her for like 5 seconds. And she was like, well, probably nothing.
Guys, I just passed out the folders, but your tests are not in there just yet.
Just in case.
Okay. Let's take a look at your U-Try and see how you did. All right, did you shift it right? 3 units.
I did.
Great. The vertical asymptote is still at y equals 0, and it just shifted right 3 units. So our domain is negative infinity to positive infinity, and our range is 0 to infinity. All right, let's take a look at number 2. This one's a little different. All right, I'm going to go ahead and graph both functions, the original function and the transformation, so we can see what's happened. Okay, there's no shift up or down, so I'm going to graph the asymptote right here at y equals 0. Okay, I will do f of x in, I'll do f of x in blue, and then I'll do g of x in red in just a second. So it hasn't shifted up, down, left, or right, so we're going to go just left 1. What is 1/4 to the negative 1? 4. It's reciprocal. Okay, 1/4 to the 0. 1. 1/4 to the first. 1/4. So this is the original function. Okay, now let's look at g of x. Well, what's the only difference between f of x and g of x? The 3. Which is a vertical stretch, isn't it? When the 3 is multiplied out in front of a function, what do we do with our graph to get it? Multiply our y's by 3. So instead of left 1 up 4, we're going to go left 1 up 12. Somewhere up here. So I'm not even going to put it because it's way up here. Okay, instead of up 1, we're going to go up 3 times that amount. So up 3. Instead of up 1/4, we're going to go up 3/4. But did it shift my asymptote at all? No, it just vertically stretched the function, but it did not shift the asymptote. So in this one, we can really only get 2 points nicely on our graph. So this 3 says to multiply the y's. By 3. So it didn't change the domain, and it didn't change the range. Okay, does that make sense? When we have a vertical stretch, we're going to our original one and multiplying our y's by whatever that number is. Same thing for a vertical compression. You would go to your y's, and whatever, if it were 1/2, you'd multiply your y's by 1/2. Okay, number 3, another U-Try. U-Try number 3. Then we'll do number 4 together.
Why is there parentheses around the 3?
That's your base. There can be. They don't have to. There doesn't have to be.
I can ignore it.
Okay, how'd you do? Did you shift it down 3 units? So your asymptote moved down 3 units? So your domain is negative infinity to positive infinity, and your range is negative 3 to infinity? Are we good?
I got it right.
Okay, cool. Yes, Ryan.
Oh, why again was there no brackets around the 3 there? Was that just with...
Because this is the asymptote that it gets closer and closer and closer and closer and closer and closer to, but never gets there.
Oh, it feels so good. Did you see that? Did you hear that? I turned my head this way, and it went like...
All right, now, this one, this f of x equals 2dx. We've done that one like 6 times. So, we should be good. We know it's here. We know it's here. We know it's here. It looks like this.
Oh, I like it, yeah.
And it has the asymptote that didn't move. So it's right there.
I have a couple.
Now, that was our f of x. So I did that one in blue. And now let's see what happens for g of x. Okay, so I go over 1 this time, up 2. Oh. Huh. What do you notice about those two
It's
guys?
reflected, but there's no negative sign.
It's reflected how?
Over the y.
It's a reflection over the y. But you're right, Matt. Usually when we reflect over the y, there's a negative sign somewhere.
Stop.
Okay, this is the function we have. Is that the same as this?
No.
Yeah.
It's a trick question.
It's yes. Because what does the negative mean? Reciprocal.
Yes.
So 2 to the negative x is the same as 1/2 to the x. So it is. It's a reflection over that y. The negative is with the x if we think about it this way. If we think about it with the same base.
But the real question is, how do you reflect over the x-axis?
Oh, there's a negative out in front. Yeah. If we had this, let's do h of x equals negative 2 to the x. It would be down here. And the range of this one would be from negative infinity to 0.
So when the negative's outside, it reflects over the x.
Just like it did in all the other functions we studied. Okay, so this would be negative infinity to positive infinity. And this is from 0 to infinity. And it was a reflection over the y. So keep in mind, when you have a negative here, it's going to be this decay this decreasing value here. Okay? Now you try 5 through 8. Let me know if you have questions.
Five through eight.
Listening to this on video. You can go to the website.